Hello, Natalie, back again. This is part 2 of the walkthrough of questions that are likely to be on the IGCSE paper 2 for foundation level. Now, if you are watching this and you are not aware of the IGCSE has calculator for both papers. So this is aimed at those people who are going to be doing the IGCSE paper 2. However, I am also going to make this available to other people as well, because I want you to be aware that, again, if it's like, oh, but I have to do that by hand, in the context of this, no, you use your calculator. Okay. And as I always say to people, you know, your calculator has to become your best friend for an hour and a half. It's not long, let's be honest. So when you are sitting there and you're thinking, I'm not quite sure what to do, and if I'm in a lesson with somebody, I will literally, because I have these little subtle things I just do. I don't plan what I'm ever going to do in lessons. Well, I do. But when a student is working through something and they're like, and I might just go and pick the calculator up and like, oh, yeah, calculator. Okay. So just try and get in the habit of, one, writing down what it is you're going to work out. And then number 2, do the actual calculation. Yeah. So just think out first, because remember, with maths, it is not just about the answer. It is about the working out as well. And that is as important as getting the answer correct. You get marks for working out. You get marks for your reasoning as well. So please think about the way you are working with your maths. So what I'm going to do now is I'm just going to pop over into PowerPoint, oops, I'm going to share. Let's come back into Zoom. I've gone into another window. It's not, I'm in something called OneNote. So I'm just going to share my screen and I'm going to go into OneNote where we have a volume. Okay. Now, just to give you a quick recap, if you've not seen any of my videos before, I'm Natalie Tarry from Mathematics Tuition. We are based in Wrexham, literally just around the corner from the football ground. So if you have been following what's been going on for Wrexham, literally probably across not just the UK but across the world, you may have heard of Wrexham. Wrexham was one of these places people say, well, where is it? You know, is it in England? And I'd be like, no, it is not in England. It is in Wales. And yeah, I grew up here. So if you know me from my time in Leicester, yes, I lived in Leicester for about 29 years. I have come back home. I am back home in lovely Wrexham now. So we are literally, I'm based in Wrexham. I can do face-to-face lessons in Wrexham, and I can do lessons online wherever you are around the world. And I mean, if you are in, you know, you've got this thing about Wrexham and what a lovely place it is, I can even sit here and do my lesson with the back to the window, if we can get the light right. And you can even have the what they called floodlights behind me. What more can you ask for? Anyway, so what I'm going to do now, this is part 2. So we have an 87-page document here that was created. I'm just going to see how far we are in now. So this is only page 13. I'm not going to go through every single question. I'm going to talk through things about these topics, because if I go through every single question, I'll still be here like in 4 weeks' time and the exam will have been sat. So volume. What is volume? Volume is the amount of space inside a 3D shape. One of my favourite things for showing this is, well, actually I've got a box, but I have my little box of crystals. So it was a lovely little box and I thought, I love that. And it's got crystals and, you know, oils and stuff in there as well. Incense and all sorts of different things in there. My favourite one? Can't find it, I'm just going to get it out now. That's one of my favourite ones. I'll drop it on the keyboard. One of my favourite ones. Anyway, so it is the amount of space inside a 3D object. And the way that we calculate it really depends on the shape itself. So I've just moved up there slightly. So the volume, if you imagine you've got a centimetre cube here, because it says centimetre cube. So all we're going to do is count the number of centimetre cubes. So we're just going to look across so we can see it's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Now looking here, there's another row behind it. So that means there's 12. And as I'm going along, I would probably write down, okay, so there's, I need to put it on annotate. So there we go. So I know on that row there is 12. Now, I have to be very careful with my pad. It's not the most up to date, so bear with me when I'm writing really slowly, because at least I know you're going to get to see it. We have another row here of 2 by 6, 2 by 6, 2 times 6 is 12. So I've got 24 altogether. And then I've got 1, 2, 3, 4, 5, 6, 7, 8. So there's an 8 there. And then here we've got 1, 2, 3, 4, 5, 6, 7, 8 behind. So that is another 8. So in total, we have got 12 plus 8, which is 20. And then another 12 times 8, which is 40. And again, reminder, with your double check your calculations. I know for me, yeah, I know what the volume is. I know how to coach students to be the best they can be. But you know what? Sometimes I make a silly mistake if I'm not concentrating. So, and I would put myself as a very highly qualified coach, tutor, what have you. Right, next one. Oh, algebra. Now, if you're watching this for the first time, you've never seen anything that I do before. Number 1, algebra. You do to letters as you do to numbers. That is very, very much something I talk about a lot. So whatever you have to think, well, if that was a number, what would I do? The only difference is with algebra is that unless you are given a value for that letter, like X, Y, whatever, Z, you have to leave it as a letter, and that's okay. It's okay to have an answer that is not an actual physical number. Okay, so let's look at this. It said expand and simplify. So expand means multiply out. And this is one of the first things I put on here is these little, that 2 is multiplying everything inside that bracket. So each one of these is a multiply. Okay, so we've got 3 times 2c. So I'm just going to write that down there. 3 times 2c. I'm actually going to pull the whole line out there. And then I've got 3 times minus 5. So I'm going to say it's minus, I'm going to do that first, the minus 5 times by 3. Because the 3 is positive, 5 is negative. So I'm going to put that negative first, just so I don't forget it. You can, just letting you know, you could have done 3 times 2c. And then you can do plus 3 times and then minus 5. I'm trying to do this on the screen. It's going back. 3 times 5 minus 5. So you can see there you're going to have 3 times 2, which will be 6. And then there's only one letter there, so it's C. And then you've got minus 5 times 3, which is minus 15. Now you get exactly the same answer if you did the one below. You just chose to do it a slightly different way. That's okay. And then we've also got this bit here, haven't we? So we've got minus 2 times c, which is minus 2c. And then you've got a minus 2 times a minus 4, which is a plus. Minus times a minus is a plus. And then 2 times 4, which is 8. Okay. So all together, so we've done the expand. So let's just remember what we've got. I'm going to do it over here. We have 6c minus 15. And then we've got minus 2c and then plus 8. Okay, simplifying now. Well, we've got minus 15 and add 8. So what we're doing when we're looking at something like this is we're looking for things that are alike, i.e. numbers. We've been adding numbers since we were in primary school, yeah? But also, just grabbing a drink, we're also looking for letters that we can group together. So for example, X might represent one number, okay? Here we've got C. Now in the context of this question, C represents a number. Don't know what it is, but what we do know is that we've got 6 of them here, and then we're taking 2 away. So what I'm going to do is I'm going to put that extra step in. I'm actually going to put those 2 together. So we've got 6C, and then we're taking away 2C. There's a minus 2C there. And then I'm going to do the numbers. Now notice I've got a +8. I'm actually going to do the positive number first. So we've got a +8, and then you've got a -15. I've deliberately done that way around. Just going to move them right at the end of my pad now. So just come over like there. Okay. So C, I don't know what it is, but I know I had 6 of them, and I then took 2 away. So I've got 4 left of whatever that thing is, C. So 4C. And then we've got a +8, take away 15. I am going to just show you that calculator. 8 minus 15 is a -7. One of the really common things that comes up here is that, well, is it a plus and a minus, so it needs to be a minus? No, not necessarily. Only when you are multiplying. Okay, so when you're multiplying or dividing 2 numbers, if the signs are the same, there's 2 are the same, positive or negative, then it's a positive. Oh, excuse me. If it is, you've got a positive number times a negative number, it would be a negative number. When you're adding or subtracting, picture a number line. If you've watched any of my videos before, you may have seen the number line where I literally say, well, what's the first number? So it's +8. And then we're taking away. So which direction are we going in? To the left or down, depending on which way you view your number line. And we're going to go 15 spaces. So we're going to start at 8, go left 15 spaces, and that will take you to -7. Okay, so there you go. We've expanded, i.e. multiplied brackets, and then we've simplified. No idea, I was just clicking on the mouse there. Okay, so what I'm going to do again is I'm going to kind of group similar questions together. Factorizing. So if you're in the exam, what does factorizing mean? Brackets. And I'm going to write here, brackets. I say it's very slow. I'm not quite sure. It doesn't seem to be responding very well. This is, so excuse my writing on here. Maybe I've turned the responsiveness off. Maybe I just need to have a quick look at it, what's going on. There we go, brackets. It's very clunky, but it's much better than what I had before. So here we have got a 3 and a 2. Is there a common factor that's bigger than 1 there? No. Let's have a look at the letters. We've got y times y, and then we've got y. So what we do is we look for the lowest power of that letter that is there. So for example, I've got y to the power of 2, and then I've got y. Well, there's no power, is there? But if there's no power, basically means it's power of 1. Okay, so the one with the lowest power, which is that one, we're going to stick outside the brackets, and then we're going to open a bracket up. Then we're going to say y multiplied by what, which is going to go here, is equal to 3y squared. And I'm going to write that down here. Y times by something is equal to 3y squared. So, well, I need a 3 in front of it for a start. So a 3. And then I've got a y times what would make y squared? Another y. Okay. And again, what I don't think I've mentioned on this video so far. I want you to listen to the questions I'm asking, because these are the questions I want you to be asking yourself when you are working through your questions, okay? It's not about the answer to this one question. I am giving you skills that you can then be better in your exam with your maths, okay? Okay, and then next one is, we have 2y. So I need y times what would make 2y? Well, I need plus 2. So 2, and then what we're going to do effectively is we're going to multiply out our brackets as a check to see we've done that right. So y times 3y, 3y squared. Y times 2, 2y. All good. Factorize again. So we are going to look for a common factor for 6 and 15. That would be 3. There's no common letters there, so I'm going to open my brackets up and say 3 times what makes 6w? And that would be 2w. And then 3 times what makes plus 15? 5. There you go. Expand out to make sure you've done the right thing. 3 times 2w is 6w. 3 times plus 5 is 15. Now, here we've actually got a common letter and a number. Oh no, we haven't actually, no. This one, common letter, you've got a D. So the only thing you're going to have outside is D, because there's no common multiple for 7 and 9. So here we're going to have G, 7G, and then minus 9E. Okay, now here we have a couple of very special expressions. Learn to recognize these, okay? So these are where you've got a square term and you have got a number. That number is also a squared number, yeah? So these are the special ones where you have 2 brackets. It's quadratic, and this is what we call the difference between 2 squares, because that's a square number, isn't it? X squared is x times x, so x squared. Minus 16 is minus 4 squared. So these are the ones that have x. So think about, what's the square root of 16? 4. So we've got x plus 4 and, sorry, x minus 4 and x plus 4. Okay. And then this one again, it'll be the same, but you'll have 7. So they're just special ones. Whether you're doing higher level or foundation or intermediate, if you're in Wales, recognise these ones because they save you a lot of time. Particularly if you have algebraic fractions, because they will save you a lot of time if you can spot them. Substitution, I remember doing this with on an exam paper yesterday. So substitution means you're a football fan, one player comes off, one player goes on. Here we replace the letter with a number. So we have got this rule that says that A is equal to, and I'm going to write it out in full, 2 lots of P. Oops, gone off the edge of my pad again. And then we've got plus 3 lots of Q. And again, I'm just going to write that on there. Okay, so now we're going to put in, when we've got P, we want to put minus 5. When we've got Q, we'll put in 7. So again, we're just going to do the same. It's equal to 2 times minus 5. Because it's a minus, I'm going to protect it with brackets just to make sure I don't forget about it. We can be very good at maths, but we can also make, it doesn't mean we don't make careless mistakes, because we think, oh yeah, we know what we're doing, run through, rush through it. Yeah, do that. Don't concentrate. You are better to take your time than rush through it and make lots of mistakes and have loads of spare time at the end. Okay? Because then when you're trying to check everything, you might miss something anyway. Okay? Right, so I've done the substitution. That'll be 1 mark. And then what we're going to do, we've got to do the calculation. So get a calculator. 2 times -5. We are at -10. And remember your calculator. Okay, -10. And we've got plus 21. And there we go. And again, I'm going to do that what I've showed you before. Now your calculator does the job. Please remember that. I'm just doing this just in case there's anyone watching this and they've not had their non-calculator paper yet. Okay. Right, so 21 minus 10 is 11. Now, we're going to make sure is I am an examiner. I've been trained and I'm going to be marking some papers for AQA. And I have to, obviously, I'm going to be going through about 400 odd GCSE papers, which I'm quite excited about. Now, what I'm going to say to you is when you're in an exam, make sure that you obviously have put your final answer. As you're going through, double check that you have finished the question and you've put your answer in here. Make sure that the answer you write in here is the one that you've come to down here, because let's just say I've done this and obviously it says 20 plus 11. You might have got the right answer here. But if you write something here and it's different, let's just say, oh, I wasn't paying attention and I saw a 12, put 12 in. Even though the correct answer is here, the examiner would think that this is the one that you're going with, okay? Which obviously is not correct. It is 11, okay? Now, substitution, again, just a quick reminder, when you've got a square number, it's 2 lots of, and it's the A that's squared. And A is -5, brackets, protect. And then we're going to do squared, there you go. And then plus 6 lots of -2. That was meant to be a 2 there. Undo that. There we go. Just pop in there, -2. Now, remember, it is only the -5 that's squared. Think of your BIDMAS. Powers comes before brackets. So you've got brackets. Okay, well, I can't get rid of the brackets here, but actually the next thing is a power. So -5 squared, remember your calculator, 25. 2 times 25 is a 50. So you've got a 50 there. And then we've got plus 6 times -12. Sorry, I've done exactly the same as I did before. 6 times -2 is -12. At least I notice these things. Sometimes I don't as I'm going through. There we go. So it's 50 -12. Take 2 off, it's 48. Take another 10, it's 38. And again, I am doing this in my head as I'm doing it when we're going along. So we've got -5 equals times -5 times 2 equals, so it's -5 times -5, which makes it plus 25, times by 2 plus 50. Okay. Right. I'm going to have a look at, we've got a little bit of solving equations. So what's solving mean? Now, a lot of these questions are very much technique based. And by that, I mean, they are directly a mathematical skill. There's not a lot of problem solving in them. So it's like you'll have learned how to solve equations. There will be a section in your syllabus. Oh, goodness me. Oh. So I've walked into town today and back, been to pick Harris up, and then I've come on here and I've been talking for a while. So just a quick recap of solving equations. Here we've got this thing, x. We don't know what it is, but we do know that, and this is a really important trick for you to remember, 7 times this number I don't know, add 8. is equal to 2 times a number I don't know, minus 3. Now, when we've got something like that with the unknown, think the x on both sides, we take off both sides the smallest coefficient of x. So we're going to take that off both sides. And I'm going to put it down here. Here we go. So we've got 7x take away 2x, which is 5x. Now remember, when you've got a number on its own, the only thing you can do with that is change it or combine it with another number on its own, okay? So we can't just say 5x plus 8 is 13 or anything, okay? Just an 8 there. Now, we've taken 2x off this side. We've got a minus 3 left. All right, so next thing is, I need that. The number that's sort of attached to multiplying the x, we keep together. And then we're going to get rid of this plus 8. We need that to go. And one of the things I've been doing a lot recently, I've been saying, okay, so that's going to go over to the other side. It's adding here. So to cancel it out, we need to find the inverse, which is minus. So therefore we have 5x equals, and I'm going to put what's there already, minus 3. And then what's coming in? Minus 8. Calculator, so we've got 5x is equal to minus 11. I think it is minus 11. And therefore x is equal to minus 11 over 5. So we're dividing both sides by 5. So we've got what we've got there now, which is minus 11, and then we're going to divide by 5. There we go. Show clear algebraic working. So if you see that, can you see what I've done here? I've taken 2x off both sides. I've then sort of divided by 5. I've done it a step at a time. So just stripping away, if you like, all the things that have happened to this number we don't know, which was minus 11 over 5. If I was to just say, okay, let's try x equals 4, x equals 2, putting it in, that is not clear algebraic working. It's got to be the steps going on. And you're always stripping away what's been done by doing the inverse, doing the opposite to what is being done in front of you. So for example, 7's multiplied by the x, and we add 8. So if that was literally, I'm just going to show this now, just say this was equal to 2 or something, yeah. So we get rid of the 8 plus 8, go over to the other side, and it would be a minus 8. And then your next step would be to get rid of the 7. It's multiplying. To get rid of it, cancel it out, we need to divide. And that would be divide by, I'm just literally doing that with my mouse there. Divide by 7. Okay. Right. But obviously we have got other stuff there as well. This one, very like what we've got above, except that we've got brackets to expand here. Yeah. So we have got 3 lots of 2z, which is 6z. And then we've got minus 5 times 3, which is minus 15. And we've got that is equal to, and I'm trying to kind of keep this at a decent level, 4z minus 11. Sorry, 4z plus 11. What about you? You know, sometimes when you're writing something down, for me, I can be the most amazing. I will stand here and I will blow my own trumpet, so to speak. I will be the most amazing tutor for you. But one of the things I do struggle with, and I will be very open about that, is my concentration levels. For me to stay on task, sometimes for me to get stuck into something can take me quite a while. And I'll flip from one thing to another. But once I get started on stuff like this, I'm like, yeah, I'll sit here all day doing this. I really would. And what was I going to say? So yeah, you know, when you're kind of doing something, so like I'm writing down, say, minus 15, and I'm looking up and it was meant to be a plus or something. I then do the opposite of what I've just said. It's so I have to pay attention. It's like somebody saying a word to you and then you write it down. Right then, so again, you've got the same here, 6z, 4z. So we're going to take the smallest one, which is 4, off both sides. Now, notice the reason I've taken it off is because at the moment, that z, 4z is a positive number, it's a positive, so we're doing the opposite, which is negative. So then we'll end up with 2z minus 15 is equal to 11. Then we're going to add 15 to both sides. Oops, let's get that on there. Then we're going to add 15 to both sides. So we'll have 11 plus 15, 26. Then we're going to divide that 26 by 2, give us 13. As I said, I'm not going to go through each of them. Right, we've got a little problem. And by that I mean, as in, there's a problem here to solve. I love questions like this. And I have a certain way of breaking it down that really will help people, okay? Okay, so we've got the diagram shows a triangle. It's not accurately drawn. Remember that. That means you can't just get your ruler or your protractor and measure, okay? So the lengths of the sides of the triangle are 3x, 3x minus 5, 4x plus 2. I often have students will say, well, we don't know what the length is. And I'm saying, but no, you've been given the lengths. Just because they're not numeric, that's okay. Okay, part of maths is we don't know what something is going to be, but we've got some information about it such that we can create a rule. This happens a lot. You're watching this now, you like have a laptop, a tablet, a phone. This sort of thing, rules, formulas, will be in your phone. If it wasn't for stuff like this, cars wouldn't be created. Your microwave. I'm trying to think of different technological things, tons of stuff. Okay, anything that requires a little bit of calculation, a bit of a computer inside it, it's got formulas in it, it's got algebra. Okay, trust me on this one. Trust me, I'm a maths teacher. Okay, so the perimeter of the triangle is 62 centimeters. Find the value of x. Okay, so this is, if you know what to do, just go ahead and do it, obviously. Now, I'm appealing out to those who are thinking, not quite sure what to do. So, what are we told? We're told that there is a triangle, and I can see there is a triangle. If there wasn't a diagram, I would say draw one, but there is, so that's okay. We've been given the lengths, and we've been given the only really other maths word in there is we've got triangle and we've got perimeter. What is the perimeter of something? Well, the perimeter is the distance around the outside. So I'm going to start in one corner. I'm going to go down there. I'm just using my mouse on my table. And then I'm going to go back down there. Okay. Again, I'm just kind of showing. So we're going to go there, and then back to the beginning. What is that then? So what is the length of the perimeter? What is the perimeter? Well, we're told it's 62. How can we link that number 62 to our picture of the triangle? What is the link? I talk about links a lot, and I'm not talking about links as in, you know, the spray stuff that we have about 6 spray cans in my office for. Not me, it's my partner. But anyway, we're looking for a link. So there is something that we can group with something else, normally set equal to, and then we can rearrange. Very, very common thing in maths, okay, in problem solving. So, well, the thing I can link to is I know that that plus that is equal to 62. Okay, let's not keep it in our heads. Let's get it written down. So I know that first length, 3x, and then I'm going to add on the next one, which is plus, and it's in brackets, 3x minus 5. Someone said to me, yes, I think might be Matt actually, says, but why do we put it in brackets? I said, because it's the whole thing. We're 3x minus 5 is a number. It's not just 3x and then we're going to take 5 away, even though that's effectively what we're doing. It's a number. And then we are going to add to it the other one, aren't we, down the bottom? So 4x plus 2. Okay, I'll just take my time, otherwise it doesn't work very well. Okay, now, all that distance we know is 62, isn't it? Because they said the distance around the outside of the shape, except it didn't say that, did it? It just says the perimeter. So you have to have done the revision to remind yourself, what is the perimeter of a shape? Okay, so link found. We've connected two things. What maths can I do with what is in front of me? So I'm kind of looking at, you might not know what skill to use. No, it doesn't tell you. But you need to find the value of x. So that's something we know we've got to do. Now I've got 3x and I've got another 3x. So I'm just going to highlight that. I've got another 3x and I've got a 4x there. So I've got 3x plus 3x, which means we've got 6x. And we're adding another 4 to it. So that means we've got 10x. Okay. Right, so now we've got minus, oops, I didn't mean to do that. Let me put that in. Minus 5 plus 2. So minus 5 plus 2, well, we know that's the same as 2 minus 5. We're just putting them the other way around, which is minus 3. So we've got a minus 3 here. So let me just check. I've got 3x is 6, plus 4x is 10x, minus 5, and again, we're adding a minus 5, so that's a minus. And then I've got adding a positive 2, so that's minus 5, plus 2 is minus 3. And I know that's equal to 62. So what I was trying to do, another good practice is actually to make sure that when you are going from one line of your working out to the next, make sure that you're only maybe changing one thing at a time. I've seen a lot of students, they'll like kind of go from, okay, I'm here now, and I think, well, I can do that, and I'm going to do that, and I'm going to do that. And then it's like, oh, why do I have to write down? Do it one step at a time, and always just bring down what's in the row above to what's below. And then look at what you've got now. So here we've got 10, lots of number, I don't know. Minus 3 is 62. So remember that little story, the 10 and the x have got to stay together right till the end. It's such a sad story when we have to separate them. Do you know what though? It helps people remember. I don't care. I don't care if it sounds the most ridiculous thing ever. But anyway, it helps people remember, and that means I'm doing my job. So we've got a minus 3 here. I want to take that over to the side and it becomes a positive 3, add 3. So we've got here 10x. And then I've got is equal to 62 add 3. Okay. So we've got 10x is equal to 65. So therefore, the thing we're looking for is x. So to get rid of the 10 is multiplying. So therefore, to cancel it out, we need to also then divide by 10. Do the same to both sides. You end up here, x is equal to 65 divided by 10. I am just going to show you just a little recap on this now. So let's just say we've got hundreds, we've got tens. I'm going to have a little break after this. I'm going to finish this. It'll be part 2. And then we've got tenths, and then we've got hundreds over here. I've not got a lot of space left. Okay, so 65. If you couldn't quite remember what to do, I'm just showing you this because if it's a non-calculator paper, which I think OCR have got this week coming up, divided by 10, we move one space to the right. So 6.5. There we go. So x is equal to 6.5. So what we're going to do now is just double check, is that what was asked of us in the question? So it's saying, well, given us the perimeter, we found the link between the lengths, and we know that plus that is 62. We then look at it and think, well, what can we do with it? You know, is there anything we can group together? And it says work out the value of x, which I have done. And it says show clear algebraic working, which is exactly what I've done here. Okay, there's no magic formula for it. It's just literally do the inverse. Do the inverse. Set things equal to what you know they are equal to. So for example, that the sum of those is equal to 62. Sometimes that will come up. I'm just going to come out of this now, so I'm going to stop sharing. Sometimes it's like, well, I know they are the same. So there might be a word in there that says they are the same. Okay, so how do I show they're the same in maths? Equals, yeah? So you've got equals. If you're saying something is bigger than something else, then you've got your inequalities. So think about, what's this telling me? What do I know about it? What does that then allow me to work out? What can I write down? And always remember, if there's a diagram, is all the information that you've been given on the diagram? If it isn't, put it on. Sometimes when you've got like a square and it'll tell you that one side is, say, 10 centimeters. Okay, well, you have to do something maybe with one of the other sides. So you're like, okay, that's 10 and that's 10, that's 10 and that's 10. It might not seem much. It might seem really obvious. But if you're struggling to see what to do with the question, these are all very, very useful tips that will, and I promise you, will help you. At the end of the day, I'm doing this because I am incredibly passionate about what I do. I really, really want as many people as I can to not suffer and find maths hard, because I know it's possible to understand it. I know it's possible for most people to do maths. I really do. You just got to have the right person taking the time to explain it to you in a way that works for you. And I always sort of liken this to me doing, like, say, something like English literature. I couldn't, it wasn't something that came naturally to me at all. And I got a grade D in it. I think I did okay with my coursework, but in the exam, yeah, interpreting poems and stuff, and I can understand now why my brain, why it kind of works that way. But yeah, I think if somebody perhaps would have given me some like scaffolding to use to help me, then that might have helped. So I'm not saying I would never ever be able to do English literature. I would say that I find it hard. It's one of the reasons I didn't do French A-level. I got an A in my GCSE in French. I loved French. Very, very eloquent. I can't remember what the word is now with languages, but yeah, the reason I didn't do it because it was French literature, and I found English literature quite hard. So it's not going to change the fact that it's French. You know, I'd rather just be good at conversational French. At that point, I'm going to disappear now because I need a break. It is now 20 to 6. So I'm going to have a little rest. I'll do a little bit more later on, and I'm going to record a few things for higher level. So if you're watching this, have a good evening. Bye-bye.